Good afternoon. Yeah. So glad to see many of you in this room. Thank you for being here. So this is our special seminar, and we have distinguished guest with us. So it's our distinguished pleasure to have him. Dr. Bin Ren from University of Wisconsin-Madison. And before I introduce Dr. Bin Ren, because this seminar is recorded, so I'll just mention this is the USF Carter Friday seminar, and it's sponsored by the Department of Civil and Environmental Engineering, as well as the Carter Center for Urban Transition Research, and also the UTCs that we have at USF. And it's facilitated by the IT student chapter. And my name is Yu Zhang, and I'm professor in the CE department. I'm the NISA director, as well as the director for the Advanced Air Mobility Program at Carter. All right, so we have Dr. Bin Ren with us, and he's a VILAS Distinguished Achievement Professor and the director of the ITS program at the University of Wisconsin at Madison. And Dr. Ren also serves as the Dean of the Joint Research Institute on the Internet of Mobility, funded by Southeast University and the University of Wisconsin at Madison. And he served as a director of the Traffic Operations and Safety Lab at the University of Wisconsin before. And Dr. Bin Ren is an internationally renowned expert in ITS and a collaborative automated driving system with the acronym CADS. And he has more than 150 patents or patents pending in the US, China, Japan, Australia, Europe, and other countries. So, given his achievement in this field, he has been invited to serve the leadership roles in international professional organizations. One of them is International Road Federation, IRF, and Dr. Ren currently serves as the chair of the Committee on Connected and Autonomous Mobility. And RF serves as a forum of global collaboration for more than 70 countries. And Dr. Ren is also actively involved in TRB, as well as the counterpart in China, which is WTC. And Dr. Bin Ren is very productive in terms of scholarship. He has 2 leading textbooks in transition planning and also 6 books on intelligent highways. And he's also the author of over 750 scientific articles. And given the conversation we just had, I got to know he already have 46 PhD graduated under his supervision. So another thing I want to mention is Dr. Ren is also a founding president of the CODA. CODA is acronym for Chinese Overseas Transition Association. And he served from 1996 to 1998. And I had the honor to serve as a president from 2016 to 2018. So you can see this 20 years difference. But I think it's a big achievement besides all others. For Dr. Ren actually is the leader in this field. So I'll give the floor to Dr. Ren, and thank you for being with us today.
Okay, thank you. Yeah, it's a great honor to be here. First time to visit the university and also campus here. I'm so happy to see Fred and also so many friends here to come to my talk and also talk to you before the session. So today the topic is about the system architecture in terms of autonomous driving. So I know you are from different fields and structures and materials, pavement and transportation. However, more or less, you will be riding a car which will be autonomous somehow. So this hopefully will have some interest to you, and as we move on. Because of the time here, I have about 60 slides. I'll run through them very quickly and guess a part of them for your interest. So part 1 is to talk about automated driving system in a collaborative fashion between the roadway and the car. So how the car can work with the roadway, become a new system. Part 2 is talk about the system architecture development for the system in particular. So how things have developed over the last, say, 8 years. And then number 3, then we're talking about, say, how we define them in terms of classification. So how we define a level 1 to level 5 for a collaborative automated driving system in particular. And then for civil engineers like us here, yeah, we are sort of behind the game for many, many years. And then the auto guys, technology companies like Google, they have been ahead of the curve for many years. So how do we catch up in number 4 in terms of putting the road into classification, level 1, 2, 3, 4, 5. And then the fifth topic is talk about how do we prepare our infrastructure ready for the future in the next, say, 5, 10, 20 years. So how do we evaluate that in terms of numbers, in terms of your metrics? The last part is to talk about the practice in 3 of the major parts of the world. US, Europe, and China, those are the 3 major horses behind all the development here. I'm very happy and also honored to serve as part of the leading organizations to lead this effort. So I will share the experiences as we move on. So when we talk about the first one, in terms of definition, yeah, so when we see the word here, it's slightly different from many parts of the other people, especially if you're from the auto industry, from the most of the world. So we're talking about you can achieve automated driving by using one or many of the following about 7 components: your vehicle, your car, your road, and your center, your cloud, and also the map. Of course, you say, okay, can I do other things? Yes, yeah, like your 5G networks, or a human user. So you can use 1 or 2 or 3 of the components. So this is a definition we think could be can live very, very long for the next, say, 30, 40, 50 years. We move on to the levels. So, okay, then we have the levels of automation intelligence, say, of the car and also the road. So put them together, then you become a different level. And you consider the allocation, say you have a level 3 car versus and plus a level 2 road. You put them together, so how the new system becomes. So that's a combination as we speak. Of course, here in between, there is a I2X and also V2X information exchange between the vehicle and also the road and between the cloud. And eventually, so we have to consider all the components we're talking about in terms of sensing, prediction, decision-making, control. So any part of the vehicle or the road or the cloud can perform 1 or 2 or 4 of the functions as we speak. So this is really how we define them. As we move on here, say in general, maybe like say 30 years ago, when we started our career, I know we have a few senior faculty here, like Fred and others. And so by that time, we're talking about automated highway systems. And then 15 years ago, so when Google started, they are talking about autonomous vehicle itself. However, regardless, as we talk about here, so if we talk about the car is not a standalone anymore. It has connectivity. So the car builds everything around the car itself. So it's a system surround the car. We call them as Connected Automated Vehicle System, the car plus others. Of course, even to make it bigger, this is how we view the world right now. Say, okay, you have the vehicle, you have the road and cloud. So this is a state of the art and also the trend of how the industry is moving today. So this will become either a coordinated system or an integrated system as we move forward. So if we put them into the box here to consider, so we do think automated driving system or ADS is a multidimensional. It can be 1 dimension, could be 7 dimension. It's a super complex system. And the core components, we do think there are at least 2, maybe 3. One is the vehicle, another is the road, and then plus the cloud become a 3rd component, which can equally function to control the automation. So when we move to the consideration here, the high-level automation, we're talking about there are many, many combinations of the vehicle road cloud itself. And as we counted, there are roughly 1 billion combinations as we speak in terms of different levels. So this 1 billion combination can go from today, 2023, move toward next 20, 30, even 40 years down the road. And so it's very complex as we move on. So this causes very diverse commercialization and also industrialization as we move forward. So you see lots of possibilities. However, eventually they will converge as we speak. Now moving to where we are here, we do believe now for the last 7, 8 years of practice of the whole industry, we do believe no matter you come from the vehicle side itself or from the combination or from the road side, they will become a consolidated system eventually. We call them as ADS. So as one thing we will keep in mind is now everything is connected. In other words, when we talk about an AAV, autonomous vehicle only, so all the vehicles have some sort of connectivity, either through the vehicle itself, like a Bluetooth, or simply through your phone. So there is no autonomous vehicle which has no connectivity. So that brings a lot of power to the system as we speak. Now moving forward here, so this is if we have faculty and students from India, and this is a typical elephant thing, right? There's not a joke, it is a story, many stories to be shared. However, as we talk about the blind people touching on the elephant itself, we are talking about different parts of it. So we, most of the world, they have been talking about vehicles for the last 15 years, since 2008, 2009. And we have been talking about road for the last 30, 40, 50 years. However, when we move on to the reality, we are touching on different parts. But we do think elephant is one. We can emphasize different things. So when we talk about deployment of automated highway system back in 1997 until now, it's almost 25 years now. So why is still not there? Everybody is not driving, not riding an autonomous vehicle yet because of the different cycles of industry barriers. So what we're talking about is we have a different life cycles and also the expectations as well. The vehicle itself, you can go from 3 years to 7 years. In the road, we can do 20, 30 years. The roadside system itself, we are talking about at least 1 year to somewhere like 7 years as we speak. And then the cloud, you can do, maybe it's a Google Cloud, Amazon Cloud, you can do maybe 3 months to a 3-year life cycle. And eventually, when you do the map itself, if you license a Here map or TomTom map, it's about 3 month updates. Yeah, you can do 1 year update. So all these things come to become a part of the system. It's a nightmare. So how do you consolidate all of them and put them into your consideration? So that's a challenge we have been facing for the last couple of years. That's why today when I talk about system architecture, we put everything under one umbrella to put them to work together as one system. Now, when we talk about that here, so when we started planning, and I had the same background as Fred when talking about demand forecasting. So that's the planning start. However, we have the design folks and design of the road, design of the car. They are in 2 different industries. So eventually, when we come together to develop the road and also the car itself to manufacture them, they have to talk to each other. So in terms of deployment, especially operations and service and maintenance and control, so that comes with the whole cycle. So now the challenge for us is, so which one you pick up? You pick up 6 months life cycle, you pick up 20 years as a road. So we have to come to the same table and agree on one design standard. So that's what we are working on right now. We are very fortunate we have settled on some of the standards as we speak. Now moving to part 2, this is a couple of slides for the system architecture. This is a moving target, has been working on that for the last almost 8 years right now. So there's some progress, however, it's not finalized yet. So as we move on here, this is one simplified way of the vehicle road cloud system as we speak. So on the left, that's a car, so the Connected Automated Vehicle. And on the right, that's Connected Automated Roadway. So on top of that, we have the cloud system, which can sit in the traffic operating center, which can also sit in the office of Google Waymo or sit in Verizon AT&T office. So that can consolidate and also sort of coordinate the 2 vehicle and road together. And under that, we have lots of supporting systems like the map, edge computing, the security systems, and the charging systems. So here are many examples here as we speak. As you can tell, I try to avoid our civil engineering. And I'm not listing any of the DOT here because the industry is pushing forward without the DOTs. It's very interesting observation. So for the last 5 years, the auto companies in the US like Ford and GM and Toyota, Volkswagen, those are probably the top 4 already we're talking about. They are using the same design regardless. So when you talk about any of them, this is the same thing. And then the OEMs here, as we talk about Continental, Bosch, Siemens, and Denso, this is from Japan. In the US, we have Visteon. So all those folks from the OEM side, from the auto industry side, they're talking about more or less the same structure. And more interestingly, as I show the next couple of slides here, so this one is a dive into the next level. The first one is the top level. This is the second level as we speak. So we move on to the second level. So for the vehicle side, you go down to the sensing and planning, decision-making control, to all the gadgets and equipment in the car. And then on the road side, you pretty much move the same thing to the road side. However, you can have a few more things because you can have bigger server on the road. And you can also have the decision-making as well as the location identification here on the road. And then under that, you have many, many things here. So you have the the edge computing itself, you have the identification system, simulation, security, and as you can tell. So this is a much bigger picture and more detailed. On top of that, now we're talking about the cloud itself. And traditionally, we talk about a central cloud, for example, a DOT cloud, which can locate somewhere not here in Tampa, probably in the north of Florida. And then if you talk with a company like Microsoft, they have their server, central cloud, they're sitting in the ocean, right? And the Amazon cloud, they have one on the West Coast, another one sitting on the East Coast. So however, we have to have autonomous driving here, the cloud has to be sitting on the road to make sure there is less computation and also a faster response. So the edge cloud and also the fog cloud can come to play. So that's the more detailed design. And then in between, so LTE now become a standard of CAVH, 5G. I will show that briefly. Now we have 5.5G and also 6G as we move forward. And now moving to the next, say, okay, how about other companies? You say, okay, previous slides, you show a few things. However, there are many other companies. So what they do here, for example, like Tesla. So when you hear Elon Musk has been tweeting, has been interviewing, right? He has been saying, Jesus, he has doing the OTA updates over the air and for his Tesla fleet. So what he does is he said, okay, I'm running a big GPT model somewhere. He didn't tell you. But where did he run? He ran in his cloud there. So, but Elon Musk didn't tell you that is he has a virtual server sitting on the edge side to give you the faster speeds of computing. So for the design here, we have Tesla, Waymo, and Zoox, and those companies on the technology side. So minimum, they have the vehicle plus the cloud. But eventually, for example, like Waymo, they run their operations in San Francisco, in Los Angeles, Phoenix, probably. I mean, I'm sure they're coming to Tampa. So when they do that, they do have edge servers sitting next to Tampa, right? They cannot have their edge server sitting in San Francisco. It's too far. So eventually, their part of the cloud will come to here to play. So this is a system, regardless you emphasize on one or other, it's the same thing. So after almost 8-9 years now of working, talking to each other, people now realize this is the way to go, including US DOT, Federal Highway, and also NHTSA as well. So the folks say, oh, Jesus, we're now coming to some consolidation. Now, to do that, to do the actual detailed design of system architecture, we need the classification. So this is a chart. Sorry, okay, they have the. So this is a allocation of the intelligence between the vehicle and infrastructure. The vehicle intelligence has been defined by SAE, which is fine, level 1, 2, 3, 4, 5. Even if you talk to Wall Street Journal guys and talk to any of the stock buyers, they know that. And however, the infrastructure itself, it's fairly new. And we presented back about 2017, and nobody believed that's the case. Now, for the last 5 years, people started to realize you have to do that. So the infrastructure, we put them on two focus. One is on the road, another is on the cloud. Cloud is part of the infrastructure. So if you are Tesla, you don't believe on the road side because of right-of-way, at least you believe in cloud. So that's part of the classification. So this is a simple function which is nonlinear. Say you have a system level 1, 2, 3, 4, 5, and then however you have to be shared and taken care of by either by the car or by the road. Somebody has to take care of it. So this function is nonlinear, has to be integer because of the industry requirements. Yeah, so end up having this allocation function, and then you say, okay, you split that, and then put them back together, and then work from there. So this is a diagram we have been showing to folks many times. People started to say, oh, this is the way they have to go. In other words, if you know the SAE level 1, 2, 3, 4, 5, it's the same thing. But difference is the same definition, SAE level 1, 2, 3, 4, 5. Now we're talking about a system, S1, 2, 3, 4, 5. And then the difference is there are 4 of those. First, information provision, and then intelligence. How do you define intelligence? That's close enough to SAE standard. And then the collaboration, integration is the one we think will be different because of the components. You have the vehicle, of the road, of the cloud. Occasionally, you have to bring the map, or you may have to bring the users, can be the driver, can be the passengers. And so those are become the part of the collaboration integration. And then the standards here, you can go from preliminary to partial to high, so follow the same type of trend. But this is a much more complex. Eventually, you'll say, who will be the lead? And either the car be the leader or the road be the leader. And then who will take over control when you have an issue or potential crash. So this will become level 3 debate when we talk about who is going to do what. Now moving to the actual stance here, we have S2, level 2, level 3, level 4. So this is a close enough definition as SAE, but at a system level. For example, we say, okay, we still have partial driving automation, but drivers still have to somehow put your hands on the steering wheel. But if you don't do that, the roadside will take over, that kind of thing, the partial automation. So level 3, this is S3, conditional automation, same thing. So your Mercedes and Volkswagen can do, and the Audis can do that now, can handle the very complex conditions on dedicated lanes, for example. So either the system does it, or the road does it, or the vehicle does it. So one part will do that. Level 4, S4 is the high automation. So you have no drivers here. However, the system will drive you through. The system can represent a combination of your car, the road, the cloud. So a combination of sharing. So this is no difference as we speak. However, the change will come with the following here from several years here. So when we talk about Connected Automated Roadway here, CAR, we are moving toward the following. So we do see the trend of revolution here in terms of information provision, intelligence on the roadside, in the pavement, and also automation on the roadside as well. So as a result, so the table here, when we present the classification, is coming into the play. So we call them as infrastructure. The infrastructure here represents a combination of your roadside equipment and also your cloud and also the traffic control center. And of course, you see how about map and others. Everything outside the car is defined as a part of the infrastructure. So we put them information provision, intelligence, automation, following the same standards as we speak in terms of I1, I2, I3, I4. I'm going to show a few examples in the next few slides. So for example, in Tampa here, we have been working on a traffic information provision for at least 25 years, maybe even 30. So the information digitization and also preliminary information provision, either by using your camera or animation, or simply you have communication to provide. So we call them as preliminary. So that's called I1. So if you count that in the US, we have the I1 level of intelligence in many parts of the road, but not necessarily in the level to support autonomous driving. So we need some tweaking and also to make sure they are provided on the centimeter level and also millisecond level. So this is a more granularized talking about, for example, how we do the sensing itself based on the centimeter level, as well as providing information of short-term prediction. This short-term, for our travel demand, like what I did before 30 years ago, we are now talking about the second by second. We're talking about 10 milliseconds, which is 0.01 second. So that's the difference as we speak. Now moving to the I2, so in the infrastructure moves up. So the requirement for that is we need some deep learning. We need some very sophisticated sensing. Therefore, they can provide up to the 0.1, 0.01 second of sensing of the system itself, especially the crash detection. That's a part of the requirement for autonomous driving. And then now this is a place you use some GPT model and to play. Now moving to the more explanation of what we mean by I2 is, so we have very high precision, sophisticated sensing, and low latency. When we talk about low latency, you have 10 milliseconds of delay of providing you information from roadside to your car. And if you have 100 milliseconds, which is about 0.1 second, like what AT&T does, well, it's probably a little bit slow in terms of providing that. And then we have the accident prediction as part of the game, but that prediction is done on a very granular level instead of the current level as we speak. And then I3, this is the one we think a dedicated bus lane can achieve. For example, say the road will drive the car. For some of us who are old enough to experience the automated highway system in San Diego, so this is more like a San Diego demo version number 2. This is a level up. But the road will drive the car. The car will become a very inexpensive piece of moving target. And then the road will take over as we speak. And then level 4. Level 3 is the same thing, but it's more connected. It's how we have global optimization and then things like that. Then I4, this is the one you say, okay, if I have no driver in the bus or in some of the fleets, like the trucks, so what are you going to do? And if you have very cheap truck or bus. And then you say, okay, my road can take care of the control, can do that. For example, like the dedicated lane itself, or the BRT, or simply the truck hub-to-hub delivery. So that's the I4 we're talking about. Okay, with that being said here, now coming to the next couple of stories as we speak. Now moving to the evaluation of the readiness. So when we talk about, if we look into the future, 2023, and typically for sites like this, autonomous driving, if you look back at the internet, internet was first invented in the 60s, right? Now until the 1990s and 2000, it took about 40 years to achieve the full functionality. So we have been debating about when autonomous driving started. So one of the common point is the time, sometime in the 80s, but not as early as the 70s. It's not there yet. So sometime in the 80s, but the first peak in the 90s. So if you talk about the life cycle itself, looking into the next, say, okay, overall about 80 years, maybe 100 years. So we are just at the first 1/3 of the curve. So we are fairly early, but Jesus. So now we say, are we ready? So that's typical US DOT, Federal Highway, or Florida DOT has been talking about how ready we are. So we need a method for evaluation. So here, this is the game here. So we say, okay, there is a long process. And when Frida and I were talking about that is, even 20 years from today, you still have mixed traffic there. We have level 1, 2, 3, 4, 5. So on the car side, Jesus, you have level 1, even level 0, 1, 2, 3, 4 in the traffic. And then on the other side, on the road side, you have the same thing, right? You have the level 1, you have the I1, 2, 3, 4 on the road side. Then same thing in the cloud. So eventually, we have to consider integrated approach of vehicle road cloud. We call them VRC, to put them together in terms of consideration. So this is how we evaluate the system as a whole. Now moving to next, what are the metrics can you use? So I'm going to give you a few examples in terms of the road, the center, and cloud. Because the reason I put center here, because we have a traffic up in center for Florida DOT, and also you have a center right here on campus to do many, many things, right? So center is always there, and then cloud can be any other places as we speak. So at least for current system architecture, you need to evaluate 3 readiness of the intelligence. So the road, the center, and cloud. Jesus, where is the car? The car is, of course. And the consumers pay for their car. And then the rest can be paid by, for example, the road can be paid by mostly the state or feds, or occasionally, if they have no right-of-way, can be paid by, for example, the enterprises. And then the cloud itself, there's a combination. So let's talk about that evaluation as we speak. When we talk about readiness itself, is a combination of the above 3 or 4. Let's use the following 3 charts here to explain. So if we talk about system level 1, 2, 3, 4, 5 here, then the vehicle itself, so if you buy from Mercedes, you can buy in Las Vegas a level 3 today. Maybe next year you can buy the same S model, which can run level 3, maybe in Florida and also in a few other states. So this is the level of the car as you can buy from 0 to 1, 2, 3, 4, right from Waymo. And level 5, don't believe Elon Musk. He's been talking that every year for the last 10 years now. So, and then on the road side, we say, oh, okay, we chop them into R here. Road itself can be 0, 1, 2, 3, 4. I think this is it. This is it, no more. And the cloud side is the same thing, 0, 1, 2, 3, 4. So from that combination, you can evaluate where you are, who you belong to, what kind of things can you work. So here, for example, the S2 as one level. This is the state of the art today as we speak. This is where industry has in terms of mass production. So all the car makers can say, oh, I have partial automation. This is level 2, occasionally level 1. And then roadside, we are way behind. It's very so we are somewhere like, no, it's hard. And outside, this is where the enterprise come to play. So we talk with Microsoft, with Apple. Each of them has a C1, C2, but they have everything ready. In other words, outside, you can go enterprise-only solution. So for example, like Tesla, yeah, what Elon Musk has been saying, they have being hired. They have been using 10,000 GPUs to run their big model to support his video. Some of you probably saw his video, right? He was just using handheld his car and to drive and almost hit the red light. And so that's his level when we talk about. And the roadside, he doesn't belong with any of the big government, so no DOT environment, no Caltrans, no others. And so the vehicle, that's a Tesla vehicle. And then on the side, the Toyota is the same thing. Toyota has been doing demos in Michigan and also in Japan. And Denso is a major Japanese supplier. So this is the way how we see that. Now moving to next. So moving level up, level 3. So level 3, currently, worldwide, they're the only 2 certified car makers, and Mercedes and Audi. Those are the only 2 officially certified by the government. And one of them, Mercedes, you can sell that, you can buy it for Las Vegas here. And then the others, Ford already listed, but it's not officially for sale. But with those, each of them is talking about a very large system of cloud to provide enough computing for their cars, and with no requirement or little requirement on the road. And then on the side, and Continental of the world, and Bosch, and Visteon here in the US. So each of them provides solutions, which some of us has been doing the work here. So this is the S3. And then S4, and you see all those new names, Waymo, Zoox, and GM Cruise and Ford, they are here because this is pure driverless. So if you do driverless, then they have to have a huge cloud here to work on. The roadside, they say no requirement, but in reality, they expect something to happen. And then those are the much newer names here. You can say, okay, I have a very advanced road. So it's automated highway system, new version. Then they say, I can do, as a mayor of the city requires, say, okay, I can sell a car to any of my citizens for only $20,000. They put almost low equipment for the car. If that's the case, this is the way to go. So this can be applied to BRT or simply the trucks. So then you can go on and on in terms of the evaluation here. So this is part 5. I'm going to spend about 5 minutes maybe 10 for the next part 6. So the above is a design or consideration for the last couple of years. I'm just summarizing them. This is not only my team's work, but also my team plus a few other teams putting together for the US and also Europe and China as well. So the following examples, so exactly where we are here in terms of major practice. So this is a chart I've been using. I'm sorry for the title, it's always there. So vehicle road cloud, I'm sorry. And so scale work, so if we stand at the work stage, what kind of things are we talking about? So until here, Japan is 1, but you can see the scale of Japan is much smaller. And so in terms of number of vehicles and the road length, number of the 4G, 5G base stations. So US here, we have roughly about, 282. So as of 2021. So this is a road length, we are the longest, 6.8 kilometers, million kilometers. However, we have only 50,000 5G base stations, very, very surprisingly low. And 4G base stations are 400,000, 0.4 million. So that's the US part. And then European part is, number of cars is amazingly the same, Jesus. So this is the European Union here, we're talking about 27 countries. And then the road length is about 4.93, about 5 million kilometers, so much shorter. And then, however, they have more communication base stations. And then China side, they have overtaken us by, it's a 417. This is moving up much higher right now. And also road length is equivalent. And then the major difference is right here. So 5G stations, 2.3 million. So they have about roughly almost half of the world's 5G base stations. And then Japan, if you consider all the numbers here as a third or a quarter of the other 3 major players. So that's why I don't list the others, because others is much, much smaller compared with the size as we speak. So this is where we are in terms of doing the work here. The part 1 is what do we do here in the US here? And many of you know we have been working on this one since early 90s. Yes, I'm sorry. This is my, when I started my job, my first job is about this one. So we're still working on this one. So currently we have a working group under TRB and to develop system architecture and with all the collaboration of US DOT, ITS Joint Program Office, and Federal Highway, and they have an office for high automation. and AASHTO, and SAE, SC, ITE, IEEE, ITS America. So everybody is involved, and also all the leaders are involved. Still, the progress, as you can tell, is fairly slow. So the objective is to develop a systematic architecture for the US and provide some guideline for the whole industry. And not only the private, but also the public as well, for vehicle highway automation for nationwide deployment in the US. And the goal here is to have guideline principles and by end of the year. So we have a draft, and then we'll have a meeting next month as well. And then to have some publication, not necessarily publication, maybe just presentation at TRV. And then next year we say, okay, we can consolidate, have a formal white paper on that one, maybe call them as a manifesto. And so this is the problem of the US here. So previously you saw the number of cars, and then in particular, we have 4 million trucks, 1 million bus. So currently the truck will stand out first, and same as bus will come because of the public service. So truck will, the reason put truck there, truck is one of the 3 major priority, not the threshold, it's more like say the working streams as we speak. Roadways, although we have 4 million miles of roads, and in particular, we focus on the NHS, National Highway System. So in that fashion, we cut down the labor and time by almost 90%. And then it's unfortunate we say, okay, 5G serves about 100 million, a third of a population. So this is where we are. The biggest challenge is the last one. And I don't know how many of you know about it. We have 20,000 jurisdictions. This is the largest and also most complex jurisdiction in the world. And then in comparable, I'll show the Europe and China as well. So we're talking about the state, city, county, town, and village. And geez, this is the toughest part in terms of reaching a consensus, not only standards, but consensus. So you have to sit in, okay, not only the process, is the time. And then that's why I'm sort of afraid when, I have no confidence when I formally retire, I can get everybody agree on. Because this is really the biggest problem. I don't think the technology side is an issue. Okay, so now moving to the actual things here. We have been reviewing the AV system, CAV, vehicle heavy automation, eventually vehicle road cloud itself. And so we have a report ready for discussion next month. And then in particular, this is the same thing. So we started from the AV itself, but we end up saying, Jesus, we have an AV here, we have an OTA, where is your GPT model? GPT is still standing in the cloud. Okay, now people say, okay, we still need the road, need the infrastructure. So then people in the industry, especially in the technology industry, they shut up. Previously, they say they can work without the road. No, not anymore. They have to rely on folks as us to provide the modeling process in the center and cloud. So that's a very, very big breakthrough as we speak. Now, this is the one people agree we can start to work with. In other words, they say we can minimize the role of the right-of-way and put more emphasis and focus on the role and on the car itself and the center and the edge computing. But eventually the same thing, no difference. So eventually say, okay, so finally say, how about this? Let's start from here. This is the way you can make it simpler by the way you want. So eventually we start from here at the guideline for the US and say, okay, if you are Waymo, you want to emphasize one part, that's no problem. But regardless, you are using part of a resource. And you may not use right away, however, you are using facility on the road. So this is really how we agreed on so far, and then we'll go down to the next level as we speak. Okay, time constraint, I will spend about 2 minutes on the China side and also on the European side. So China side is much simpler. They have 3 society, and they have SAE and also highways like AASHTO, ITE, communication, and also there are many like Volkswagen, Toyota, GM, Ford, Qualcomm, everybody's involved because also it's an international consortium. It's called VRCIC. And then under that, they say each of them, they manage all the roads, manage all the cars, manage all the communication. So it's a little bit simpler as we speak. And we move to the details of the detail. Eventually, say 3 society and all the companies have to agree on the part here. They call them as acting concert. So standard setting, same technology platform. More importantly is the next one. So they are trying to adopt a high-speed rail approach because this one turned out to be a success. So they have the longest high-speed rail So eventually, talking about 10-year time frame, 10 trillion RMB, about 1.5 trillion US dollar project and program to make it happen. So this seems to be closer to our reality because they say each of the societies have their own roadmaps and system architecture. They're trying to put as one. So in the next two slides, so this is a roadmap as we speak. So in 3 to 5 years, they have the sensing in collaboration level 1, and level 2, they have the decision making in collaboration level 3, which is about 2040, 2050. Eventually have the collaboration control between the road and vehicle. So that makes life very consistent and easy. So this is, again, the definition based on SAE in terms of level 1, 2, 3, 4, 5. And this is the level of collaboration integration in terms of sensing, decision-making control, and this all the functions as we speak. So this is being adopted in China. And then very interesting is European folks are now taking over and say, hey, this is interesting. We just use it. Say, no problem. In the US, we have been struggling a little bit. I believe at some point we will use it because as Fred and I will know, even 30 years ago, it's the same thing. We just didn't change much. The only thing changes the progress of communication technologies and also AI modeling and GPT, and as well as some of the computer programming stuff. So that, I think things will happen very quickly. So the last 3 slides are the European folks' work in terms of the architecture design. So IRF, as Yu has been talking about, has a committee on connected autonomous mobility. I'm chairing that. And so we have been working with ERF, which is the European Road Federation. Eurodico is like Europe, is ITS Europe in that fashion. And FISTA, this is a global organization on SAE. They have 35 countries. And then plus many other auto companies, OEMs. So this is a work has been going on for 3 years. And so eventually adopting the same thing as we speak. So the first product here is a white paper manifesto on vehicle road cloud integration system, and next summer. So they already have the draft of next summer. And then in a 1.5 years, they have a white paper on the overall architecture. They make it broader. They call them as collaborative connected autonomous mobility. In other words, they try to make sure it covers multimodal, not only the roadways and also the transit, even the biking, and also the terminals with the trains and things as such. So make it broader. So this is the European work. And then, as you can tell, so this is limited to 27 countries only. And UK, they are there. When even it's part of European Union, and it's part of it. If it's not, it's not. And then this does not include other countries. In total, Europe has about 44. So this is a little bit to 27 only. But even with that, there are some small countries which has only a couple of million people. So the work is now easy in terms of consensus building, and also the good thing is that at least they're adopting the same standards of car, the same standards of roadways. So that make our life easier. And so this is really a quick catch up. I think this is the last slide. Oh, okay. So, okay, everybody is in the same thing. So now I'm very happy and also confident to report after about 7 or 8 years of work, now at least the major players worldwide are consolidating into something which we can agree on. And it took many effort and lots of meetings. And also about, I think even the most stubborn people start to change because they believe coordination, consolidation, integration is the way to go. And there's no winner if you stick with the road or stick with the vehicle. The vehicle will never be smart enough to achieve everything which can be affordable to any people, especially the working class. So that I think that's the consensus built already. Like Tesla, for example, you can go maybe $100,000 Tesla, but that's not be affordable for to any of the citizens, especially for new grads, for example. So now we say in order to reduce the cost of the car, you have to rely on the cloud and also road, period. So that's my short presentation, and I'll entertain for questions, comments, or criticism. Yes, please. That's a great question. Yeah, it's a great question. So and I can't have a long answer, but I'll give you a short version first. Yeah, so you can put them into 2 categories. One is the enterprise, another is the agency. So let's talk about enterprise first, because that's the one that move much faster than agency, because many of us here work with DOTs. We know how slow they are. And so enterprise, so for example, now the leading the cloud itself, man, we have only 3 or 4 in the US, right? The Amazon, Microsoft, and Google. And however, and Tesla, I'm sure they're going to use its own cloud. The building up, I mean, Elon Musk already built a huge farm of GPUs, at least 10,000. He said he's adding more and more as he speaks. So the dollar amount he's talking about, like he was saying, I don't know if it's true, it's $20 billion. So I don't think that's true. He's just quoting. Sometimes he may discount that by 10%. So that's a part. All of the enterprises will go regardless. So maybe some of the familiar names at Google itself, its own cloud, and GM Cruise, maybe they were just licensed and also rent. And same as the other major players here in Florida or in Michigan. And so that's the enterprise version. And then there are 2 major players in that category. Another one is automakers, GM, Ford, and Toyota, for example. Another category is the Verizon, AT&T, the operators. The reason for that is they already have their server farms located along the roadside. So you receive, for example, you drive on some of the interstate or freeways or major roads, your signal is not bad, right? So they have their base stations and server room located over there. So those can become the first part. So those are the 2 major players in addition to the one I talked about. The agency side, it's a different story. Because the US here, we're talking about 20,000 jurisdictions. So each of, like Florida DOT itself, I'm sure they have their private cloud. And then because of the security. And then in the meantime, they also rent the public cloud for like charging, for example, the user interfaces. So that's the one which can happen slower. But eventually, if we talk about how fast they move in terms of commercialization or industrialization, and the road will go faster, and cloud probably will do the same. So eventually, the cloud investment will overtake the road and also will overtake the vehicle itself. Think about, I mean, you have a fixed budget every year by Florida DOT, right? How much did they invest? Sorry. Thank you.
Yeah, so I'm very interested in that when you're talking about the low intelligence level, because for government, the one very interesting. However, as you mentioned, those car manufacturer, the OEM, a lot of time they are just cannot wait for government to get everything,
right,
and so
right.
they go ahead and do whatever they can.
Right.
And there's a really big motivation for for them to make profits. And for the cloud system you mentioned, they also the private company, and there's also a good motivation for them. And so for government agencies, and because I saw several the one you talk about different.
Sorry, I couldn't go back to the slide.
Yeah. I saw those intelligent level 0, but you got other with a level 3 or 4. So what's the motivation? How the government agency, how they can move it forward faster, and how can we, what's the motivation for them, and how can we contribute on that?
Okay, yeah, great question, great question. And then, in fact, many of us here, including yourself, have been working with the DOTs and also FAA for many, many years. They are very, very slow in terms of moving. And so there are 2 ways of to motivate them. For example, we have been working with the mayor of city of Arlington, Texas, for example, and also city of Racine mayor and Wisconsin. So from their perspective, and they have a couple of ways of, one is to promote their economic development as a tool to promote that. Another is that to improve their consumer, their jurisdiction, and also their stakeholders, and how they can appreciate technology, right? Yeah, especially a place like Dallas, for example, they try to label Dallas to overtake Austin as a way. So that's one angle. So the mayors have their way to sort of help on that. And then another part is, it's very unfortunate that US DOT is well, I'm a professor. I'm okay to say. Yeah, for the last two administration, from the previous NHL and the current one, and so they think this is a good thing. However, they don't have the. I cannot say they don't have the will. They want to do something. However, they do not have the resources to do it. Think about the budget here we're talking about, right? We're talking about even on the infrastructure bill give us about almost $360 billion on the road side. I mean, overall, right? However, out of that, I mean, a large chunk of that goes to the charging stations. So in order to make it happen, to back to your question is, one thing we could do is just focus on some of the major corridors as we speak. So currently, for example, if you go through, I'm not familiar with Florida. However, I can tell you that is, in Midwest, we have the I-94 corridor going from Michigan and Detroit and going to Chicago and going to Wisconsin and also Minneapolis. That's the one people have been working on closely. And then we also have the truck corridor as well. So if the city or the state, they really want to promote economy and improve the quality of life here, then they probably focus on this corridor as we speak. And another corridor which we can, for example, like Iowa, going through all the West. So there are a few of those is the way we go. So eventually, I think we have disparities as we move on. But yeah, go ahead.
And do you think the liability is a concern for the government agency? Because a lot of time they are afraid somebody's going to sue them.
Right.
And so they are waiting for other people to do. And if they're successful, then they follow up.
Yeah, the first mover will be sued for sure because I think the U.S. Congress and also the state, also U.S. Senate as well, together with some of the states, some of them are very friendly in terms of sort of making their laws much more friendly to the technology we're talking about. The reason I'm saying here, for example, the reason why I took the approach of going from top down is, if there is no top down, you go from the ground up, Jesus, you end up
very difficult.
You can end up nowhere. Especially the guys who say, oh, you cannot do it here. You move to another place, you come back, right? So even I spend another 100 years, I mean, I don't think it's going to happen. Yeah.
Thank you. I think your presentation was really great.
Thank you.
Yeah. And as for my question, I know this wasn't discussed in the presentation in much detail, but I'm kind of interested in how does Japan, how do they manage and control their connected, collaborative, autonomous mobility system?
So your question is, how do you manage and control the what?
How do they manage their connected, collaborative, autonomous mobility system? Because we know we discussed in detail how Europe manages their system and as well in China, but
the Japan, you're asking Japan?
Right.
Okay. You're not from Japan, right?
No.
Okay. Yeah, we do have folks last week from Japan asking me what's going on there. And okay, so Japan is very interesting. Japan is very, very simple. Because Japan, I don't know, you know the geography there? Japan is like a chain, right? Like Florida. So all their distribution of population and also roadways along the coast. So if they take care of their coast, they're done. So it's like Florida, either you go, I don't know, on the Tampa part or on the other Miami side. That's it. So Japan is much easier to do in terms of work and also the planning. Another good thing is Japan Japan is a very good follower. They're not really the first inventor. So whenever we decide on the things we're talking about, they just learn and adopt. They don't even ask. So I don't even go to meetings in Japan. I just say, you guys, you come, you go. It's up to you. I think one thing, the chairman of Toyota made one comment, which I think that's their belief is, they say they want to produce one car which can be sold and run on any part of the world, any part of the roadway with no change. So that's a philosophy from GM and Ford as we speak. So it's the same thing. So in that way, I think Japan's attitude is probably more progressive. Yeah. So I think they are very, very flexible. Yeah. Yeah. Yes, please.
My question is, let's say we have automobile. So let's say we already have all these autonomous vehicles, level V5, everything is big road that you presented. How would that change the car designs themselves the way our transportation is, if we can already do everything done, we gotta change the rules of driving, how it's gonna affect all of it.
Okay. Yeah, it's great. Let me understand your question. And so you're saying when things are happening, autonomous driving, the vehicle industry, because you asked a couple of questions there. So the auto industry, how the auto industry will be changing in terms of design of the car, and also the same as the road as well.
Right, how do you envision all the rules we have?
Right.
Change that.
Okay. Yeah, you're asking 3 questions. Let me just repeat the one. The reason, yeah. So I'll go from the last one first. The rules is defined by is decided by a couple of organizations. The first one is like NHTSA, National Highway Traffic Safety Administration, which Fred's expertise, and then another part is by the state itself. The state, for example, the state troopers and police, and of course they go to the assembly, right, for approval, everything. However, the city itself has a way. So it's unfortunate in the U.S. we have 3 or 4 tiers of the rule making. But in a simple way of saying that is the way in which we are pushing for in terms of system instead of vehicle or road only, that can address some of the issues you're talking about. Because we simultaneously changing the rule of driving. In the same way, we are also changing the rule of designing of the roads. Because people have been joking about, say, in the future, if every car becomes autonomous, do you need the traffic sign? Do you need the signals, traffic lights? They say eventually we do not. However, before that day, that will be another 30, 40 years. So you still need those. And so back to your point of rule changing here. Say, are you going to change that highway design standards as some of our faculty are teaching? So that's not going to change soon. But we are prepared to change it as needed. So in some of the locations and roadways, we're going to change. So one analogy I just want to always make is, I was just talking with Fred about it. So now we are migrating from a horse carriage. Minimum the horse carriage is like traditional human driving vehicle. Now coming to the age of, say, you have the gasoline powered automobile or SUV, and it's the same story. So when you talk about horse carriage, and then you need the autobahn, you need the freeways, you need traffic lights. So that's about almost 100 years ago, at least 80 or 90 years. Now we're entering a new age. So now horse carriage cars become auto, now become of the connected vehicles. So the same thing has to happen on the road. So eventually they come together. So we can now use the old, say, okay, you design the rules of driving by the car. No. You have to also decide on the rules of designing the roads. So eventually, so the room in this room, we have to work with another room in electrical computer, and we have to sit in the same table and make the same rules. I'm sorry, it's a long answer. Yes. So for this part is, so typically a system architecture, for some of us who are old enough, in the US ITS architecture, we spent about 3 years and $50 million. And then even today, we're still using that. However, this one, we spent $0. Nobody's paying. So USDOT say, oh, we'll give you a couple of $1 million. But when the money is here, that will be another 2 years. So things are already finished. So from this level to the next, there are 2 parts. One is going down to the design architecture. So enterprises such as the automakers, technology companies, they took it from here because they know they have some confidence. Say, we're going to make sure the roads are using the same standards as we speak. So then they will took that for their part. And next part is in terms of our road infrastructure of civil engineers, we'll take it from here. Jesus, we are designing something which will not become useless or obsolete. So that's the next 2 levels as we speak. So standard setting, follow the architecture. Sorry, it's a huge industry. We have millions and millions of people working on this part, but we have to sort of talk about the same language. Yeah.
Thank you for the question. We have the question. So I saw some keywords on the slide. For example, you mentioned about drive the vehicle while
Sure.
the vehicle does not.
Right.
Now, the question that you also mentioned about decision making, right? So the question is not about the technology, it's more about if we have decision making that could be contradicting
To each other. Yeah,
objectives.
right.
So how that could be considered, and also is like when the system will override the vehicle. Imagine when like the system control everything, it's kind of scary. So have that been discussed? Or?
Right, has been very, very much addressed as well. So when we talk about, that's why people like to use, like European folks like to use autonomous. So that which means you have the decision power by yourself. No matter it's automated, it's automation is supported by the road, by the car, but the final decision maker has to be the owner and user of the vehicle itself, of the system itself. So in other words, you have a contradiction, especially come to the safety. We say, well, you mean, say, you're going to hit a pedestrian, right? I mean, if you hit the pedestrian, you will survive. That's the same. And then if you don't hit, you will die. So that's a trade-off. For that kind of particular situation, what's your answer? You're going to die, sacrifice for the life of the pedestrian? Probably not. Everybody is selfish. So what typical rule we have been say, okay, if that things happen, which will happen for sure, then who owns what? You do the best for you. There's no optimization. Because eventually we come to the lawsuit, right? Jesus, you say, okay, the two, I mean, one died, one didn't die. I mean, who died first? I mean, that's become the big thing. So there's no court, no judge for that. And but you buy the vehicle and then you own it, all the insurance pay for that, and then they take care of that first. I know it's very, I'm sorry, it's no good answer. Yeah.
About the,
Sure.
so I think developing higher level automated roadway system, and so that the less sophisticated vehicles or cheaper vehicles could run in the system. It's kind of collected the money from public and use it for some purpose instead of, so this is some similarity.
Sure.
Yeah, so,
Right.
And then when you compare Europe, US, China, Japan,
Right.
Different countries have different systems.
Right.
So in some countries, it's easier to go in certain direction.
Right.
Yeah. So how? Because you're serving on the.
Yeah, I'm sorry about the. Yeah. Right.
Countries.
Right.
What is your comment?
Well, you have to really follow the locals. Yeah, for example, in the US, I mean, we think jurisdiction will have the final say, and then we have to stay with that, no matter. So we used to be the leader. I mean, I'm sorry, I mean, not the leader anymore. But how behind we can be left? That's a question I keep asking all the folks. Say, hey, you guys, you say we are 10 years behind. Then do you feel comfortable if we are 20 years behind? Then people started to say, no, probably not. That's the time we start to invest. And this field moving so fast, everybody can imagine, right? So 5 years later, I'm sure, I mean, we have to maybe US Congress will pass a new law requiring this and that. So because we are talking around the table for the community, for the committees, but people are moving and working. So you can, I mean, that's my observation, I think. Yeah, we can sleep for another 5 years, at most 3, and then we have to work. I was thinking, should we consider this area centralized? Should be able, you can define the level of centralized the problem about that? Okay, let me understand your question. I think we're asking two parts of that. One is about computing, decentralized, right? Another is the application to the car. The reason I'm repeating some of the question is because we have so many guys interpreting the same language in all the directions. Trying to make sure, so you're talking about distributed computing first, then apply to your car, not applying to the road, right? Okay, so you're asking that kind of perspective. Okay, good, good. Yeah, this is what I face every day. Say, okay, need to ask it, what's your affiliation? If it's an auto company or it's a technology company, they speak the same language, but the language, the interpretation is very different. Okay, back to your question here. So distributed computing will happen, is happening today as we speak. So I don't know which sector you'll be working for. If you work for the agency DOTs, that's a slow process. However, you work for Waymo's of the world or for Tesla, and it's happening on a daily basis. Especially the reason for that is the GPT model come to kick in as a major driving force. So any of the innovation here, as we speak in the autonomous driving, they have to carry a slogan or band or slogan say, I have a big GPT model. Either call them as Drive GPT or whatever. That's how they make stories. That's how they attract money. However, to make that work, you need distributed computing. You cannot say, I have my server farm in the Pacific Ocean, and then not transmit back to take about 100 milliseconds. That's not going to work. Yeah, simple answer, yeah. So that's definitely a place people like us here can help, because they call them as edge computing or fog computing. We call them as simply a server farm right here, right? Yeah, so that's the part which many of our models here can work.
Do you have any questions? Audience, if you have questions.
For the online attendees, do you have any questions? All right, if not, I think that's it for today. And I want to thank Dr. Binran for your presentation. Thank you so much for being here with us today.